So I thought I'd just give you a little bit of a run through on the kinds of variables we're going to measure on these cores and that you're going to be working with your collection of artifacts for the final assignment. So the first thing, of course, is going to be to record things like raw material and overall size, but we'll focus first of all on core type. So here I've got a few different core types lined up. I've got single platform core here, so you've got the Cortex on the surface, an old scar here, not one of the new scars, so not counted as part of core rotation. So single platform core, all the flake scars coming from that platform. Then we could think about our multi-platform cores. So here's got a nice piece of desert opaline chert, and we can see flakes coming in multiple different directions on this core. So that's going to be our multi-platform core. Another example here in Silkrete. We've got flakes coming in different directions off different platforms. So that's our multi-platform core, and the code will be MP in your database. Then we've got our bidirectional cores. So here we can see our scars coming from two directions, opposed directions on the core, and our platforms at the end. So quite a thin core, that one. Another example here, a little bit thicker, but with scars coming from two directions. Then our blade core, our code being BC, blade core. So here we've got the long, thin, the long, skinny scars on the front of the core, which are indicative of the manufacture of a series of blades, in this case off a single platform. Our previous blade core that we looked at here is a bidirectional blade core. And then finally, we could think about our bipolar core, which has a code here of BIP, bipolar. And here we've got our Cortex on the back, and we've got the crushing at two ends, actually on all sides here, indicating it was placed on an anvil and crushed from above. Okay, so each one of these is going to have a different platform type, which is our next variable. This one had the Cortex with one scar, but we'd probably just call that a cortical platform. In this case, we'd call the, just as we did on our flakes, we'd call the platform multiple scarred, or maybe Cortex and scarred together. In this case, we clearly have a faceted platform on the core, so you can see the facets, the faceting which come from the core face onto the platform. So that's indicative of faceting, and we have that on both ends of this bidirectional core, since both platforms were being prepared to flake those blades. Same again on this one, lots of faceting on the platform. So lots of those little flake scars coming from the edge. Our single platform, so in this case we'd just record that as a single flake scar. There's actually two, but in the case of most single platform cores, we're just going to be recording that as a single scar. And then in the case of our bipolar, we've got the crushed ridge as our platform. So there's no flat surface remaining, faceted or otherwise, or cortical. It's all crushed off, giving it that very crushed ridge appearance. Okay, so those are our main platform types. Then we're going to do some things like take some measurements. So we can take the length of the core. So here we're going to be talking about the longest worked face on the core. So we know that there are lots of different places we could measure length, but what we want to do here is we measure the longest face of the core. So here we're going to be measuring 55 millimeters, and then we're going to take the width at 90 degrees to that point. So this is telling us it's got a very short core face and a very wide core face. And then we'll take the thickness at 90 degrees to that. So we've got, once more, length, width at 90 degrees, about halfway down, like so. And then at the same point at 90 degrees to that, thickness. So that would be telling us we have a short-faced, very broad and quite thick core. On our multi-platform cores, we usually select the last face that was worked. So here we can see our last big removal came from this platform down onto this core face. So our longest face in this case would be that face there, and then our width like so, and thickness through the middle to the back. Okay, so we don't need to repeat that on all the examples, but basically the same sort of thing on the bidirectional. Your longest face will be this face here that's been worked with the opposed flaking. Same on our platform, on our blade core. This will be your longest face. And then again on our bipolar core, we'll be looking for the main axis of flaking as our longest flake. Okay, so then we're going to measure cortex. So just like you did on flakes, you're going to be thinking about this as in kind of 10% increments for the entire core. So for this core, we've got an old flake scar here and an old flake scar there. So we'd just consider this cortical area, and we'd probably call it something like 60 or 70%. So only 30% of the core area has actually been worked. On an example like this, we've really only got cortex remaining on these two faces, so we might be calling that more like 30 or 40%, and so on. On a piece like this, only a little bit on the back, so maybe 10 or 20%. Same in this case, maybe only 10% in this one. But in this case, most of the core still remains cortical, so it could be 50 or 60%. And likewise on our bipolar, a lot of the back of the core there is cortical. Actually, only about half of the back of the core is cortical, so about a quarter. So we might be saying 30%, something like that, of the overall core is cortical. As for the cortex type, so just as we did on flakes, you'd be saying, you know, is it a rounded sort of cortex, a pebble type cortex like we see on these two? So you call that rounded. Or is it an angular flat kind of cortex like we see on this one? So we might call that angular. And in some cases you might get very irregular, lumpy kinds of cortex, a bit more like what we see on this one. Sometimes it'll have strange protrusions and things, and we call that irregular. Okay, in terms of numbers of scars, so we're not going to bother counting all these tiny little flake scars on the edge here. These are our overhang removal flakes. Don't bother about those. Just count the larger number of flakes that you can see there. So it might be sort of 1, 2, 3, 4, 5, 6, 7 flake scars on this core. I won't do this for each one, but as you'll see on each of the cores, there's going to be a series of small flake scars around the edge, like you can see on this one. We won't bother about counting those little tiny ones. We'll just count the longer ones. And my general rule there is maybe longer than about 15 millimeters are worth counting. But of course on very small scars, very small cores, like this little bidirectional microblade core, many of the scars are actually smaller than 15 millimeters. So just use your judgment on that. Next, we are recording number of platforms. So on this example, our single platform core, we just have one platform. On this one, our multi-platform core, we've got one platform here. We had an old platform on this surface as well, so that's 2 platforms. And if we look around, maybe we'll see another platform on the base as well, 3 platforms. So we just go around the core, turning it around. You can use your fingers as a guide as to where there are different flake directions. So you can say 1, 2 over here, 3 down here, or whatever. And you can sort of rotate the core and count it up that way. On our bidirectional cores, it's very often just 2 platforms at opposed ends. Okay, next is the number of flaking directions. So sometimes you won't actually have clear platforms in evidence. You'll just have old truncated scars that indicate that there was once a platform in a different direction. So take a scar like that, for instance. We don't have any indication of where the platform is. It's long gone. But we know that there must have been a platform over here somewhere. So we might say that there was an extra platform that we can't see anymore. So we can't see the direction of flaking anymore, particularly. So we can add up the number of platforms, and that might be different to the number of flaking directions. Okay, now the length of the longest scar. And for this, literally, you're going to look over the core, find the longest scar that you can anywhere on the core. And it doesn't matter if it has a platform or not. So if, for instance, we find that the longest scar on the core, let's just say for existence, is this one for the heck of it. So this one is a good example of what I was just talking about. We have our main platform here. So we've got one platform, but here we can see 2 flaking directions. There's no platform left anymore, but we can see evidence of a second flaking direction. Now, that's probably not the best example of the largest flake, but let's take this one here, for instance, where we don't really have the initiation anymore, but we can still measure that as the longest flake on the core because it's the longest scar there. And we'd get a measurement of 108 millimeters long for that scar. So again, just turn the core over, look for the longest flake scar anywhere on that core and measure its length along its percussion axis. So using your ripples and your termination and initiation points and so on to guide you as to what that percussion axis would have been. Another thing that is really useful is to go over your core and look for the number of non-feather terminations. And this can be an indication of how much stepping and hinging is happening as the core is being flaked and often being rotated. And often the more often it's rotated and the smaller it gets, the higher number of step and hinge terminations we get, particularly relative to the number of flake scars. So you could actually calculate a ratio of number of flake scars to number of hinge and step. In this case, we've got 1, 2, only 2 scars, only 2 hinge scars or step scars. And that's giving us an indication that probably, because this is still in an early stage of reduction, we've really only got 2 or 3 platforms and the scars are big, not really experiencing too many problems in terms of edge angles getting too steep and lots of step terminations building up. But when we look at an example like this, where we can see the edge angle is very steep now, almost all of our scars are hinged or stepped. So we'd count those up, 1, 2, 3, 4, 5, 6, etc. around the core. And finally, if you have a blade core in your assemblage, or even if you don't have a blade core, you might want to count, or we've got here, you're counting up the number of these long parallel-sided elongate, so length more than 2 times more than width is what we define as elongate. So count up the number of these long elongate parallel-sided scars or tapering scars, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So a very large number of the scars on this core are going to turn out to be blade scars because it's one of these bidirectional blade cores. We'd still be looking at these scars on the back, so we might say 60 or 70% of the scars on that core are blade. In this case, maybe a similar sort of thing, maybe higher, maybe 80%. Again, if we're not factoring in little tiny overhang and faceting scars, just the bigger ones, our blade scar count's going to be very high relative to the overall number of scars on the core. So that should give you an indication of everything you need to know to fill in your data table for your cores in your assemblage for the assignment for the end of semester.